All right, so I'm taking a bit of shortcut here. Let's look at the solution. It says use a a suitable substitution to determine this integral. So if we're looking for a suitable substitution, we want the square root of x squared minus 4 to simplify to something nice. So you can see that they've used x equals 2 sec theta. If we use 2 sec theta, if we square it, we get 4 sec squared theta, and so you can see that here. And it works out really nicely because sec squared minus 1 is tan squared, so we can change that to tan squared, and the square root of tan squared is tan, so square root of 4 is 2. Just note, whenever we use these trig substitutions, we're looking in the first quadrant because sine, cos, tan, so everything in there is positive. All right, so sometimes we just assume it rather than say it. We probably should say it. So, and we also know that if x equals 2 sec theta, then dx is 2 sec theta tan theta to theta. So because we know that, it makes it really easy to then substitute. So instead of dx at the top here, we're going to write 2 sec tan to theta. And x squared down here, that x squared comes from our 4 sec squared theta. And then we've already simplified to 2 tan theta. If we put all the constants out the front, we get a quarter. And we end up with just a sec theta in the denominator, which is the same as cos theta to theta. All right, so when we integrate cos theta, we get sine theta, but we need to go back to x's. So how do we do that? Well, remember what we did substitute in. We said x equals 2 sec theta. So x on 2 is sec theta. So that means 2 on x is cos theta. So if you draw your little right angle triangle and put the adjacent over hypotenuse as 2 on x, there we go, so the 2 and the x. Use Pythagoras to get the third side. And now we can do it quite easily. So now when we're trying to find sine theta, sum opposite over hypotenuse gives you the square root of x squared minus 4 on x. So we get our solution. Now remember it's a definite integral, so we're actually going between 2 plus epsilon and 4, so 2 plus a tiny bit and 4. Now that's just a straight substitution when you do that, so we get this answer. And the whole point of doing that is to say, right, now we're going to look at the limit as e gets really, really, really small, so it goes towards 0. So if we do that, you can see this second part here will just go towards 0. So we just get root 3 on 8 as our solution.